Hello, my amazing math students. This is Mrs. A, and I love math. Today, we're in lesson 82 of your Saxon Orange Book, and we're talking about evaluating functions, domain, and range. Now, back in a previous chapter, we talked about functions of x, and this was back in chapter 28. We talked about functions in x. And that means that for every output, there's just one output for every input. Okay? And back then, I drew you a little box like we sometimes see on cartoons, a little like an assembly line in a factory. And this function box, we go into the function box with an input, and we come out with an answer, and there's only one out for every in. So functions are predictable, and functions are fair. So basically, I always describe functions in this way, okay? If you went into the store to purchase a drink, okay, like a slushie or something like that. You went into the store to purchase the slushie, and the person at the cashier said, okay, one slushie is $2. And so you plunk down your $2. And then somebody that is the best friend of the person who's running the counter at the store walks in and says, I want one slushie, same size and everything, and you had just walked away a few steps, and they said, for you, that slushie's only 50 cents. And you go, that's not fair. Why? Because you both purchased the same size slushie, but yours was $2 and someone else's was only 50 cents. And that's not fair. So that's what it means when it says for every input, there is only one output. For every slushie of a certain size, you can depend that you're going to pay the $2 and not get changed just because you happen to be the favorite person of the person behind the counter. Okay, so functions are fair. For every input, there's only one output. They're predictable. You can tell what's coming. Remember that when we're talking about this f of x notation, that's called a function notation. And f of x is the same as the y in any equation. So we've got x is the input, y is the output, or f of x is the output. So another way to say it is just one y value for every x value, or just one function value. The y is the function value. So just one function value for every x input or every x value. Okay, so here in your book is an example of a function that they've written right here. F of x is x squared plus 5. Now, into that function, this notation, f of 1, means we're going to take a 1 and put it there for the x, which means we're going to substitute a 1 in place of the x squared. So 1 squared plus 5 is 6. Then f of negative 1 is equal to negative 1 squared plus 1. Well, negative 1 squared is also 1. 1 plus 5 is 6. Notice that I have two different inputs but only one output. In that case, that's not a problem. A function has only one output for each input. If the input changes and the output is the same, that's okay. That is still a function. Okay, it's not two different outputs for a single input. It's two different inputs that happen to get the same output. That's not a problem. That would be like going to the store and getting a slushie for $2, and then going a different time or the same time and getting a candy bar for $2. It's not a problem that the candy bar and the slushie happen to have the same price, is it? Okay, but if the same slushie has two different prices depending on whether you're that favorite person or not, that's not fair, is it? But it's perfectly fair for a candy bar to be $2 and then a slushie to be $2. Does that make sense? Okay, so we continue with f of 2, meaning that a 2 is plugged in place of the x. So we get 2 squared, which is 4 plus 5 is 9. F of square root, the function of square root 2, is square root of 2 squared, which is 2. 2 plus 5 is 7. Okay, notice that in each case, the number that is here is substituted into the place of the x in the original formula. And that is how functions work. F of 1 is 6, f of negative 1 is 6. That's no problem. Just like a slushie and a candy bar being the same price would not be a problem. What would be a problem is if f of 1 turned out to be two different things. Okay, so here's our first example. We have f of x equals x squared plus x minus 10. And we could say that as function of x. And function at 5, or f of 5, is going to mean that everywhere I see the x, I'm going to plug in a 5 instead of the x. So I'm making a substitution in there. Am I not? I'm substituting the 5 for the x. Everywhere I see the x, I put in the 5. 5 squared is 25 plus 5 minus 10. 25 plus 5 is 30. Take away 10 is 20. So the value of f of 5 is 20. Now here's a different one. Now we're going to plug in an h of a squared. And yes, that means that everywhere we see an x, we're going to take out the x and put an a squared there. So here we take out the x and we put an a squared in place of the x, and then we square that. Plus, we take out the x, we put it in a squared where the x was, plus 1. So it's a handy thing to leave a little parenthesis when you take the x out and then just plug in the value you're supposed to plug in there. So a squared squared is a squared times a squared, which is a to the 4th plus a squared plus 1. And that is the value of h at a squared. Okay, so here we have f of x and f of x plus 2. So this is our function, but now we're going to replace every x with an x plus 2. So now we're going to take out the x, put in our little parenthesis, make it a little bigger because we have a little bit more to put in there, put our square plus our 1. So now where the x was, we're going to plug in an x plus 2. This one's a little trickier because remember that x plus 2 squared means x plus 2 times x plus 2. X plus 2 times x plus 2. Some students make a mistake and say that x plus 2 squared is x squared plus 2 squared, which is definitely not the case. All right, so we're going to end up multiplying these together using our FOIL method. So remember our FOIL, first, outside, inside, last. We're going to take the first 2 and multiply them together and get x squared. We're going to take the outside and multiply them together and get 2x. We're going to take the inside and multiply them together and get another 2x. and then take the two last and multiply them together and get plus 4. And then finally, we're going to add our plus 1 at the end. And if we do it right, it makes our little foil man. Makes our little Martian face, right? If we do it right. So first, outside, inside, last is our little pattern. And so now let's put it all together. X squared. The 2x and the 2x equals a 4x. The 4 and the 1 equals a 5. And there we have it. X squared plus 4x plus 5 is the value of f of x when we plug in an x plus 2. So we would say that this is the value of f of x plus 2. It sounds like you're really, really smart, but it's really not hard at all, is it? Okay, so now we're going to start talking about domain and range. Now, domain is really easy because if I were to say, what is your domain, or an animal's domain, we would say that's where the animal lives, or where you live. This is my domain. This is where I live. So we can say the domain of a function is where x lives, or more accurately, what x can be. All of the possible values of x would be the domain of the function. Likewise, all of the possible values of y would be the range of a function. So domain is referring to what x can be. Range is referring to what y can be, or the output of the function can be. In this book, we're going to always assume that x is real. X is an element of the real set. Okay, that means x could not be 3 divided by 0, because when we divide a number by 0, it is undefined. It is not real. Or it cannot be a negative underneath a radical sign. That would not be a real number. Okay, so we're going to say those are not in the domain of x. We're not allowing any x's that are not real in this textbook. If a number is real, then it is in the domain of x. It is one of the legal numbers for x to be. Okay, so x, domain, y, range. Domain is what x can be, all those possibilities, and range is what y can be, or the output of the function can be. Here is your book's formal definition. A function is a mapping from one set called the domain to another set called the range, such that each element of the domain is mapped to precisely one element of the range, and each element of the range corresponds to at least one member of the domain. In other words, we can't have members of the range just floating around there not being caused by a member of the domain. Now, it can be more than one member of the domain. So basically, all real numbers are a possibility here. Each element of the range corresponds to at least one member of the domain. So if we can't have any floating y values, is what they're saying. Everything in the domain should cause only one output, but an output could have more than one input. That would be all right. And I'm going to show you an example of that later. Now let's read this next part before we go into the examples. It is, so basically, another way to define the domain and the range of a function is as follows. Domain of f is the set of acceptable x values, or set of inputs. The range of f is the set of resulting y values, or the set of outputs. It is much easier to determine the domain of many functions than it is to determine their ranges. In the examples as well as the problem sets, we will usually ask students to determine the domain of the functions, because determining the range is harder. Okay, you will do that though in later courses. We will only ask for the range of the function if it is immediately apparent. So they're going to be kind of easy on us in this book and not ask for the range unless it's very easy to figure out. Okay, so on this one, if f of x is 2x, find the domain and the range of the function f. Now, one thing that will make it a lot easier for you to figure out is is there something that x cannot be? Now, we've already talked about x is always going to be a real number. Is there anything that limits x to something more narrow than a real number? Okay, so basically, if I put any real number in, can I double it and still get a real number out? Yes. Okay, real numbers are anything that will fit on our number line. So I can't say that y, or the range, will always be even numbers. Even though I multiplied it by 2, what if the original x was 1/2 instead of an integer? So I'm going to say all of my domain is real numbers and my range is real numbers. I started with real numbers, I double them, I still have real numbers. Okay, so we have a very interesting function here. We have f of x is 3. Well, remember I told you at the beginning of this video that f of x is the same thing as y equals 3. That's a line. That's a line that's going through the y-intercept of 3. This line is this function. But let's look at, suppose we didn't have the line there. Could we say that x could be any real number, because we don't see any reason why it would be limited? But no matter what x is, this output is always 3. Okay, so the range, nothing but y is 3. The output will always be 3, no matter what the input is. There's no x in the function, is there? So the domain is all real. But the range is simply 3. It can't be anything else. In the next example, we have a picture instead of a formula. And notice that it stops at 3, 4, and it has a hole at -2, 3. So when we're describing the domain, we're describing what can x be. Well, x is going all the way from -2, but realize it's not included. -2 is not included because of the open circle. And it's going all the way without any breaks until x is 3. So we would say x is an element of the real, okay, such that, that's what that little line means. And then we're going to say -2 is less than x is less than or equal to 3. I lost my room there. -2 is less than x is less than or equal to, because it can be equal to the 3, but it cannot be equal to the -2. Okay? And then for our range, I'll start a little bit farther over. We have y is an element of the real, and we use our little brackets there. Should have one over there, but we ran out of space, such that now we're looking at how high and how low it goes on the y. It does not go below 0, does it? But it does look like 0 is a point. So we're going to say 0 is less than. Now we're looking to say, okay, what's the highest point? 3 is not the highest. 4 is the highest. And it does go continually up to 4. So 3 is less than y is less than or equal to 0 is less than or equal to y is less than or equal to 4. Because it does look like it touches 0. and it does look like it touches 4. So 0 is less than or equal to y, is less than or equal to 4. And then for the domain, -2 is less than, not equal to, because of the whole. -2 is less than x is less than or equal to 3. But in both cases, when I'm talking about the domain, it's x as an element of the real. And when I'm talking about the range, it's y as an element of the real. Let me see if you can see that a little better there. Now you really have to put on your thinking caps for this one. We have a function, square root function. Okay, now we know that real numbers is all we're talking about in this class. And if I have a negative number underneath a radical, it's not a real number. So in order for this to be real, 5 minus x must be greater than or equal to 0. If it's not, I go negative underneath a radical, and that's not real. So now I need to get this inequality into a form that will tell me what x can be. Okay, so now I'm going to say, all right, I'm going to leave the negative x there. I'm going to subtract the 5 and subtract a 5. And I have negative x is greater than or equal to -5. But I never want a negative x. What happens when I multiply everything through by a -1? I'm going to multiply this side by a -1. I'm going to multiply this side by a -1. And doesn't my little inequality sign flip over? And I'm going to have positive x is less than or equal to +5. Okay, so only when x is less than or equal to 5 will I have a real number going in. Okay, now, if x is less than or equal to 5, then this number in here is going to be greater than or equal to 0. Since this number in here will be positive, won't my square root also be positive? So my range is going to be positive. And this will be my domain. So basically, I would say x is an element of the real such that x is less than or equal to 5. That would be my domain. And then for my range, I would say range is y is an element of the real such that, and then I have to designate positive. Y is greater than, it's going to be positive or 0. It could be 0. So we'll say greater than or equal to 0. So this part first, and then this part. So this is your domain where you're dealing with x. This is your range where you're dealing with y. Okay, so that is a little bit different, requires a little bit higher thinking skills, but you've got them. So on that last example, the range is y is an element of the real and y is greater than or equal to 0, but that was a little bit higher reasoning. And they didn't ask you that. They only asked you the domain on that one. I did a little extra. Here's our last example, and then we'll start our practice problems. What is the domain of g of x equals 1 over x? Now, they're not asking you the range because it's a little harder. But remember, when we're trying to find the domain, we're trying to find out what x can be. So a good way to do this is say, what can x not be? Now, I can let x be any real number, and I just have a fraction. But x cannot be 0, because if I divide by 0, that is not a real number. It's undefined. And so we can't use it. So we would say here, the domain is, put our little set notation here, x is an element of the real such that x cannot be equal to 0. That means that any other real number would do, but x cannot be equal to 0. Okay, so here we have f of x, And we're to find f of m squared, which means we're going to take everywhere we see an x, we're going to put a little parenthesis and we're going to shove m squared into it. So let's rewrite our equation. F of m squared. Now I took out the x, I'm putting in the m squared. Now I'm going to do that all the way across. 2x squared, but in place of the x, I'm going to put m squared, plus 3x, but instead of the x, I'm going to put m squared, minus 5. And then all we do is simplify. So m squared squared is m to the fourth. So we have 2m to the fourth plus 3m squared minus 5. And that is f to the m squared. Okay, here's our next practice problem. So copy it down, then go pause your video. Try to do it on your own. See if you get it right. Okay, so here's our function, g of x squared minus 4. Find g of m plus 2. So g of m plus 2 means that everywhere I see an x, I'm going to put an m plus 2. So g of m plus 2 equals, take out the x, so x squared, parentheses squared, and inside I put m plus 2, minus 4. Now remember, m plus 2 squared is not m squared plus 2 squared. I have to multiply it out using FOIL. So m plus 2, m plus 2. Remember, FOIL, first, outside, inside, last. The first gives me m squared. The outside gives me a 2m. The inside gives me a 2m. And the last gives me a 4. And then I bring down this minus 4. And I get m squared plus 4m. And those cancel out. So m squared plus 4m is g of m plus 2. Okay, so get that on your notes if you did not get it down, because these are your practice problems. Okay, so now we have a domain and a range problem. F of x is 3x. Okay, now remember, a good way to do this, we already know that all domains must be real. And we must have real outputs also. Real inputs, real outputs. Now, what is going to give that to me? Is there any x that I could put in that when multiplied by 3 would give me something outside the real number line? And the answer is no. There's no real number that I could multiply 3 by and not get a real number. Therefore, I'm going to say that the domain is all real numbers, so because all x's are allowed. So I'm going to say x is an element of the real. That's the domain. There are no other restrictions. And then the y, or the range, won't that always be real? If I take a real number, I multiply it by 3, wouldn't I get a real number out? And the answer is yes. So the range is going to be y is an element of the real. There's nothing else that you have to write because there are no other specifications that are necessary. Okay, so here we have g of x is 2. Notice that 2 is a constant. That means this is a y equals 2 because g of x is the same as y. This is a horizontal line. Okay, so basically I could throw in some points just so you can see this. So suppose x is 1. Won't g of 1 still be 2? So wouldn't the point 1, 2 be on the line? And then, well, what if I make x 50? Won't the output, or the y, still be 2? What if I make x negative 10? Wouldn't the output still be 2 because there's no x over here, is there? So x has 0 effect. So x can be anything, and the y will always be 2. So if we graphed these points, 1, 2, 1, up 2, 50 is way, way, way over there, but it'd still be up 2. Negative 10 is way, 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 way back here, but it'd still be up 2. And we would have a horizontal line. Y equals 2 is the name of that line. Okay, so for our domain is x is an element of the real, and our range is y equals 2. There's nothing else it could equal. Okay, so here we are on our next to the last practice problem. We're getting there. Okay, so now we have a V shape again, a little lopsided V shape. Now when we're talking about the domain, we're going to say how far left does my x go? Okay, so this looks like a continuous draw all the way across, but this is a hole. So we would say, okay, it goes all the way to the x value of -1, and then this is x, and then this goes all the way to the x value of 5. All right, so now we have to think about open circle means that it's just less than. The x is greater than the -1, or -1 is less than the x. There is no equal to because that is a hole. And then we're going to put the less than or equal to 5 because 5 is a darkened circle. So that means the 5 is included. So the domain would be anywhere in here. So now to make it specifically, let's back this up a minute and say x is an element of the real such that -1 is less than x is less than or equal to 5. Okay, so that way we have specified that we are talking about only real numbers. Then we're going to do the range. So range, we know, starts with y is an element of the real such that, now we're going to look at y goes all the way down as low as -1. That's the lowest point. And it actually touches there, doesn't it? So less than or equal to y, less than or equal to. Now, this one is an open circle, but its 2 is lower than the 3. So we're always going to go with the higher point, and the higher point is a closed circle. So we would put a 3 here. Okay, if the higher point were an open circle, then that would have been just a less than instead of a less than or equal to. So we have our domain and our range for our next to the last example there. Here we have our last practice problem. We have the square root of 3 minus x is g of x. Now remember that all of our inputs and outputs will always be real. So this must always be greater than or equal to 0, or it's not real. So we're going to say 3 minus x must be greater than or equal to 0 in order for this square root to be real. So now we're going to solve this. Okay, so let's subtract 3 from both sides. We get -x is greater than or equal to a -3. But we don't want a negative x, we want an x. So we're going to multiply both sides by a -1. And we're going to get x, and when we multiply by a negative, doesn't that flip over and become a less than or equal to? And that's going to become a -3 times a -1, which is a +3. So our domain is x is an element of the real such that x is less than or equal to 3. And we have finished our lesson, and this is Mrs. A, and may God bless your day.